All right, last set of examples here. We're going to be using our trig ratios. Okay, so just as a reminder, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, there's also a little bit of work that we're going to have to do ahead of time before we use the trig ratio. Okay, and that is going to be to find the measure of one interior angle and then cut it in half. Okay, and I think best to explain that would be to just jump into these examples. Okay, so when I look at this octagon here, if I know that one of the side lengths is 10, that means I know that this part here is 5. Okay, that apothem cuts the sides in half. Okay, so all I know right now about this triangle is that that shortest side is 5. Okay, right here, this side is 5. Okay, now finding the measure of one interior angle, that, gosh, what chapter was that from? 180 times n minus 2, and then divide it by the number of sides, since they're all the same. Okay, this tells me that the measure of one of my interior angles is 135 degrees. Okay, so that's like this angle right here is 135 degrees. Okay, now why do we cut it in half? This radius cuts that interior angle in half. Okay, so when we do 135 divided by 2, that gets me this angle right there. Okay, so we've got the measure of one of our angles and one of our sides. Now we are looking for this side. We don't know what that side is. Okay, that's our apothem. So I'm going to go ahead and label these. This is our opposite side. This is our adjacent side. This is my hypotenuse. Okay. Opposite and adjacent, that tells me tangent. My page keeps scooting down on me. Okay, so the tangent of the angle, so 67.5, is what we don't know over that adjacent side. So to find that missing side, we're going to take 5 times the tangent of 67.5. And that tells me that my apothem is about 12.07 inches. Okay, so we'll go ahead and round these apothems to the nearest hundredth. Okay, and now that we've got the apothem, we can find the area of this octagon. Okay, we found that our apothem was about 12.07. The side length is 10, that's what was given to us. And then an octagon has 8 sides. So multiplying that tells me that my area It's 482 and about 482 and 8/10 square inches. Okay. All right. Next example, we've got an equilateral triangle. Okay. We have, again, we're given our side length, but we don't have our apothem. Okay. So looking at this smaller triangle inside first, my apothem cuts that side in half, so this portion is 7. Okay. 100, goodness. 180 times the number of sides minus 2 divided by the number of sides tells me that one interior angle, which we know of an equilateral triangle, is 60 degrees. But when we cut that in half, that tells us the measure of this angle right here. Okay. And that radius cuts that interior angle in half. So we've actually got a 30, 60, 90 here. 7 represents our long leg, okay? But if you don't want to use special right triangle patterns again, we can go ahead and use trig. Okay, we're looking for that opposite side. 7 is our adjacent side. Here's our hypotenuse, but that's not pertinent to our problem here. Okay, we're still going to use tangent. We don't know the opposite side. Our adjacent side is 7. So to find that missing piece, that apothem, we're actually going to take 7 times the tangent of 30. Which is about 4.04. Okay, once we have that apothem, then we can go back and find the area of this equilateral triangle, a little bit differently than what we've found areas of triangles in the past. Okay, our apothem is what we found. Side length is what we were given here. Okay, and then the number of sides is 3. So this area is about 84 and 84 hundredths square meters. Okay. Next example. I want you to pretend like this 10.9 isn't here. Don't know how that snuck in there. Okay, but we are given the apothem now. Okay, and we don't have the side length. Okay, we're going to start the same way by finding the measure of one interior angle and cutting it in half. Okay, so 180. The heck? 7.5. 180 times 5 minus 2 divided by 5 tells me that one interior angle measures 108 degrees. Okay, but we don't want the measure of one whole interior angle. we want the measure of half of the interior angle. Okay, so this angle here is 54 degrees. Okay. And we've got our apothem, but what we don't have is half of this side length, okay? So if I'm going to label these, 7.5 is our opposite. This missing side is our adjacent. Okay, so I'm still using tangent. Okay. So x times the tangent of 54 equals 7.5. So to find that missing value, we need to divide both sides by the tangent of 54. Which is going to be about 5.45. Okay, now 5.45 is about half of the, it is half of the side length. So to find the entire side length, we multiply that by 2, which means our whole side length is 10.9, which is what was given to us at the beginning. Okay. So we're going to use that and the apothem that we were given to find the area of this pentagon. Okay. So 1/2 times the apothem times the side length times the number of sides tells us that the area of this pentagon is about 204.375 square meters. Okay. Last example here, number 12, we've got another octagon. Okay. And we have the apothem, but we don't have the side length. So that's what we're going to work to find first. Okay. I'm going to draw this a little bit bigger, actually. There we go. Okay. So still start by finding the measure of one interior angle and cutting it in half. Okay. 180 times 8 minus 2 divided by 8 is 135. And 135 cut in half is 67.5 degrees. Okay, so that's this angle right here. Our apothem is 8. And we don't know what that portion of the triangle is right there. Okay, so label your sides. 8 is opposite the angle. This missing part is adjacent. Tangent is very popular. But this time we've got 8 in the numerator and that missing portion in the denominator. So to find that missing part, we've got to divide both sides by the tangent of 67.5. Which is about 3.31. Okay, but remember that only represents half of our side, so we need to multiply by 2 to find the length of the whole side. Okay, and then we use that to find the area of our octagon. So 1/2 times the apothem times the side length times the number of sides gives me an area of 211.8 4 square inches.